Great. So good morning, everyone. 11 o'clock, we will start in 1 minute. Just put hi, hello, whatever you want in the chat, just to see that chat is working. Good morning, Rohit. So yes, chat works fine. Cool. We will give it 30 more seconds and then we'll get started. Hopefully you can see my screen. Can somebody confirm on the chat? Awesome, awesome, awesome. In this is 30 seconds, right? So tell me, since COVID, right? When the COVID started, what are the two buzzwords in security you have heard or you have heard a lot, right? So two buzzwords, put it on the chat. What buzzwords have you heard since COVID? I'm looking at the chat. So we have 5 minutes, right, for initial introduction. So yeah, you are ZTNA is fine. Okay, ZTNA, data privacy, ZTNA. Yes, WFH, remote VPN. Suha Prakash, we cannot hear you because you are on mute. All the participants stay on mute till we get to the Q&A session. So yeah, ventilator, Vitali, very true. And then yes, cloud, SASE, hybrid work, cyber security, no admin rights, O2. I have still not heard anybody saying AI. Right, because this session is of ZTNA, so people are saying ZTNA, SASE, which is fine, but nobody has said AI. Now comes the AI. Great, guys. So you have guessed it right. ZTNA is one of the most talked about subject, and what you see on the screen is today we are going to discuss with Nishikant, who is joining us from Zscaler, and Nishikant will demystify various aspects around ZTNA. How the traditional VPN are not scaling, they are not effective anymore. So we will see how ZTNA can help us, can help enterprise CISO to scale to new level and secure their organizations, right? That's what our topic is going to be today. And from the agenda perspective, again, as we do initial 5 minutes of welcome, set the context, and then Nishikant will have good 40-45 minutes to talk about the ZTNA perspective from Zscaler side. And then at the end, we will save about 10 minutes for Q&A. We will issue CP certificate. We will also do our Wheel of Fortune. And the giveaway for today is smartwatch, right? So that you can track your steps that you are doing. And you can also use your digital smartwatch for the stand and attend challenge, right? So this is the stand and attend. What you do in stand and attend is that you stand for the elite knowledge session, right? You do not sit on your screen. So Nishikant, you have been to the Elite CISO webinar earlier as well. Next time when you come, you have to take this challenge, right? You have to stand and then present. Okay, so guys, it is good to take this challenge because you can see on the screen, if you take this challenge, you will have all these benefits. So do not let these benefits go apart from the great knowledge that Nishikant is going to share. So if you accept this challenge, go to the chat and say yes, you are accepting this challenge. Recording is happening right now. I've enabled the recording. So if you want to review it later on, you can go to the Elite CISOs YouTube channel. I will show at the end how to access the recordings. The previous recordings are already there, and it is great to see people are accepting the challenge. Really appreciate that. It is still 11:03, and I'm saving 2 minutes and passing it on to Nishikant for a very interesting session. With this, over to you, Nishikant. I am going to stop sharing my screen now so that you can share yours. I still see two people in lobby. I'm gonna clear them, and then yeah, Nishikant, you can start.
Thanks, Vikas. Let me switch. I hope I'm audible.
Yeah, you are audible. Yeah, you are
Okay.
audible.
Okay, perfect. Sorry. And the screen should be loading up by
Yeah,
now.
I
Just
can I
let
can
me.
see your screen.
Perfect. Okay. So thanks, Elite CISO team for giving this opportunity again. Now I'm back on the same forum, but with a different objective this time. And the message that I'm trying to convey today is how organizations have realized that VPN is no longer the safest way to reach or to connect to the crown jewels. By crown jewels, I essentially mean applications which are traditionally hosted in private data centers or public cloud, and how they're shifting or embracing the zero trust essentially. And what is essentially the problem statement with traditional VPN based remote access VPN based solution, right? And what I'm going to do for next 35 or so minutes, I'll try to stay in proper timeline today because I sort of tend to go deep into some of the things which I want to stick to the topic today. What I'm going to do for next 30-35 minutes is first I'll walk you guys through what are the typical challenges that we have seen in the market, what our customers have been telling us that okay, this is the problem that I see. These are the external entities like they're reporting okay, these are the vulnerabilities out there in the wild. You need to patch this up on the traditional VPNs that are exposed, and now shift to a better security solutions, and how organizations are sort of dealing with this sort of challenges daily, and what makes them shift to ZTNA framework essentially, right? So that's essentially the topic that I'm going to cover, right? So let's start at the very beginning, right? What was one solution, now it's a problem, right? Like, what do I mean by that? Essentially, uh, initially, the way it started was we had a nice, good and data center, traditional castle and more approach where all the apps were placed inside a centralized data center, right? Maybe DCDR, and users were either on-prem. As long as they were on-prem, they were on the routed connectivity, they could directly reach to these applications, right? So all fine, no issues. The moment users stepped out, the way uh, and that's where the VPN exposure started, right? And the reason why VPN was originated was to give a notion, a false sense of notion to the user that they are, even though they are away from the data center, away from the corporate office, working from home, working from office, wherever they are working from, they should get sense that okay, as if they are working from office only. And VPN was a way to do that, because what VPN used to do is that, or VPN does, is that it puts the remote user directly on the network, right? Especially IPsec and all, right? And what do I mean by that is you guys would relate to this is, for example, if I dial up using an IPsec connectivity, uh, and some form of an IPsec VPN client. What happens is I actually get an IP range which is completely routable on the data center network, and then I can actually figure out, okay, fine, I need to connect to app.acme.com. Okay, this is the IP of address of the application, and that could essentially be funneled through the IPsec tunnel, right? So this is more or less the way communication on IPsec works, and giving a false sense of notion to the user that okay, fine, you are as good as on the land, right? Now, imagine a scenario now that the world has changed and the applications are spread across different locations, right? One of the ways you could access the application is VPNing into data centers, and now the applications have shifted to multiple cloud or hybrid cloud environment, so to speak, where a part of applications are there on the data centers and some of them are on hyperscaler like GCP, AWS, or Azure. Now, what you would do is to reach to data center and then use these direct connects, interconnects, express routes of individual hyperscaler, which are terminating into data centers, and then VPNs are facilitating the connection to these hyperscalers via one anchoring point. And this, while this was again one of the first step where ever since this application modernization started, right, that explosion started, is the first thing that network security team thought is that okay, let me get, because my concentrator is there in the data center, let me bring everyone to the data center, and then I will fork them off over the direct connects express routes, and then land them on the GCP infrastructure, AWS infrastructure, or AWS or Azure infrastructure, right? So that was the first thought. And it was, as you can see, it's very cumbersome, where it's not really suited for multi-cloud infrastructure or a hybrid workforce because of the sheer the way the traffic is getting routed, right? And why this VPN architecture essentially creates an issue is, uh, let's understand how attackers try to exploit this, okay, by going step by step. You have your data centers, you have your VPN concentrators there, right? And now you've expanded to branch and factories, depending on your manufacturing or wherever it is. And then you have shifted to public cloud infrastructure also, where some of the applications are there on AWS as well as Azure. And these public cloud locations are actually connected through a direct connect or interconnect fabric extension to your data center, right? Now, you have these firewalls again, which are extended and built this sort of like a connectivity, VPN connectivity from branches, factories to hyperscalers. And then what ends up happening is that you have ended up with all this mishmash of connectivity using either VPNs or L2 extension. Wherever it is possible, you will use this direct connect circuits, or otherwise what you would do is that you would use some form of VPN to extend the connectivity, right? Now, what does what the if you can see, look at the animation, what this has done is that the red line essentially indicates that you've created this routable domain across your multi-cloud hybrid cloud infrastructure, where potentially a user or any packet can route once it's admitted on the VPN connection, right? Now, the first thing what attackers do is essentially they will find you, okay? Because obviously, if I know if I'm doing some targeted attack against an organization, and what I would do is that, for example, Acme is the organization. I don't want to call out any organization right now, but let's suppose Acme is an organization. So in a typical sense, if anyone wants to figure out what are the namespaces associated with it, what they would do is that they would just do DNS reconnaissance. And in the DNS reconnaissance, they would identify, okay, what are the domain names registered against these entity? And they would essentially be doing namespace sweep on the internet, and they would figure out, okay, there looks like vpn.acme.com, vpn dot or ipsec.acme.com, right? Which is getting used by the VPN clients or your employees or contractors to reach to your applications, which are either hosted on public cloud, private cloud, wherever it is, right? And that's where this reconnaissance exposes the attack surface, exposes the public IPs, because by nature, the way VPNs are hosted, VPN gateways are hosted, these gateways are actually physically there on the hyperscaler, your subscription, right? Inside your subscription, or inside your data centers, and you have to use your public IP to expose that to the outside world, right? And that exposure correlated with the reconnaissance ends up giving that attack surface exposure to the attackers. Once they find out that this is the public IP, using the well-known CVEs out there on the internet, and I'm going to talk about this in a couple of slides. They would compromise you, right? All they have to figure out, okay, fine, I'm maybe running XYZ vendors for a VPN client, right? So excuse me, VPN gateway. Now they could just do some additional advanced reconnaissance and figure out, okay, fine, it looks like this is the operating system, because each OS, each operating system of VPN gateway gives a specific fingerprint, and then the remote vulnerability framework can identify, okay, fine, this looks like that operating system number, and that operating system version has this VPN vulnerability. And this is not rocket science. And even a script kiddie can just run a metasploit, do some Google search, and figure out, okay, this is how I need to figure out, this is the operating system, this is the VPN gateway that is running, and this is the vulnerability associated with it. Because some of the things have become very simplified nowadays with these frameworks which are used for exploitation, right? So once they know, okay, fine, this is the vulnerable operating system or vulnerable cryptographic implementation on VPN gateways, they would compromise you. And once it's compromised, these red lines, which were earlier a means of users to access application, becomes like a highway for attackers to sort of move laterally and figure out pricey essentially your crown jewel resources. And crown jewel resources could be, they would try to figure out where the active directory is. And worst case scenario, like I'm assuming that by freak of nature, like the first thing that they end up landing on is an active directories. Like, for example, if I end up exploiting that user's communication or end up snooping the network packets, right? What would end up happening is that it's easier to understand where the AD endpoint is, because every time authentication happens, the user try to land on active directory, and they would figure out, okay, fine, that this is the IP which belongs to active directory. And if active directory is compromised, user, that attacker can potentially get hold of all of the credentials which are hosted on active directory. And then that can be used to log on to maybe critical services like file servers, web application servers, and then that where the confidential data lies. And then they can steal the data, exfiltrate the data, and take it to, hypothetically, a file server on the internet, and either hold it hostage, or option one, or maybe just sell it on the black market. And that could be impacting your overall reputation, right? So that's and what I'm showing you right now, this has been this has happened with if I'm not wrong, 2 or 3 NBFCs here in India itself, where because of the vulnerabilities and because of the vulnerabilities there in the VPN endpoints, VPN gateways, uh, the attacker were able to insert a payload, discover the Active Directory, farm the credentials, land on the critical servers, exfiltrate the data from the critical servers out there, hold that for ransom, deploy BitLocker, lock the systems, and then just make cripple the whole infrastructure, right? So that's also like the way that was executed. Kill chain is exactly like this. Now, if I were to how this is coming back to the point, like how easy it is to figure out what are the vulnerabilities, right? So there are, if you just do a Google search for VPN vulnerabilities, there will be more than hundreds of millions of articles. But if you can just filter out to VPN vulnerabilities, specific CVs, you would find, depending on the keyword, somewhere between 7 million to 10 million Google search results, right? So how secure is this remote access VPN, right? Because it depends on, see, as a best practice, the secure SecOps teams will always end up playing this uh, a chicken and egg game with attackers, where sometimes vulnerabilities released, and by the time vendor releases a patch, you have to wait for it, unplug it, do countermeasures, some secondary countermeasures, supplicant countermeasures to make sure that that vulnerability is not exploited till the time vendor releases the patch, and so on and so forth, right? So that begs the question, right? How secure is the remote access VPN, right? Now, going back to the earlier point that Vikas had mentioned, that you can actually use the chat GPT also. And I'm going to focus on one specific vulnerability that has been going out there in the wild, which is the Ivanti one. I'm not trying to bully, or like, I'm not trying to say that, okay, vendors are wrong or something. That's the way technology is designed. And every uh, uh, OEM will have developers who will try to design code to the best of their effort. But sometimes you will end up using a library which might have inherently some form of vulnerability which gets released at a later point in time, or something like that, right? So the recent one we all of us know is the Ivanti one, which is the Pulse Current Secure, which was released. So if you can just go to the Chat GPT and show me, ask Chat GPT that show me the top VPN vulnerabilities that were reported by CISA recently. These are the ones which would sort of immediately pop up, right? And I'm certain that all of us knows that Ivanti was the latest one. Like, I think it was released on Jan 10th or something like that. Now I'm going to focus on this. The reason is because it just gives you the sheer volume, or the way chain happens, and the way organizations are trying to respond to it, and how difficult it is for everyone to sort of keep up with this sort of vulnerability challenges, vulnerability exposure challenges that VPNs are posing, right? Like, for example, on Jan 10th, Ivanti ended up exposing Connect Secure and Policy Secure product vulnerabilities, and they were very critical. One of them was bypass authentication, and the second was the run command injection exploit, right? I'll talk about these two, what these two are. And then by Jan 12th itself, within 2 days, we at Zscaler ourselves were able to see there was an active exploitation observed in the wild, right? And by Jan 19th, we saw that there was an emergency directive released by CISA to sort of patch these vulnerabilities, telling enterprises, organization, okay, you have to fix this quickly, as fast as possible, right? And there was two additional vulnerabilities by Jan 31st, which were released, which allowed privilege escalation and server-side request forgery exploits, right? Which means you could actually run the server-side code execution, nothing on the client side, right? On the remote far end itself, the communication. And on the same day, CISA actually gave a supplicant direction to physically remove the Ivanti devices and perform remedial action before bringing them back online, which is very troublesome, because you're actually asking enterprises to disconnect the cable of that VPN gateway and just run it without VPN till the time things are fixed. And by February 1st or 8, like, additional vulnerabilities were discovered and patches were released, right? So this has been happening, and the problem is quite this was the emergency directive that I was talking about. Like, this is specifically for federal agencies, but then this was given to enterprises also. Like, you have 48 hours to just disconnect the cables from that Ivanti Connect Secure or Policy Secure, and then make sure that it's fixed first before you connect it back online. The reason is because there were these two flaws. And the reason I'm categorically highlighting this is because every time a CV is released for the VPN gateway exploits, we need to understand what is that CV and how it's going to impact. The first of that was authentication bypass, the ability to log in to affected that VPN product without username, password, or MFA, which essentially means that it's as good as no credential login. I just have that payload of exploit, and I'm just there in the VPN, right? Which it's very scary, right? Which means the VPN is no longer, it's just an open door for anyone to just come inside. And the second is command injection, which is ability to run scripts on the VPN server and allow escalation of privileges and further lateral movement in the network, which essentially means is that first of all, I'm inside the protected workspace without any security guard asking me, okay, to declare my identity or ask me and posture check or something like that. Nothing of that sort. And second of all, once I'm there, I can just like roam around freely, door to door, stealing packages, and no one even asking me a question, right? And the worst part is that the exploit code was publicly available, and it's very scary. And the remediation was like, okay, what should we do in such a scenario as an organization? So forget of Ivanti for a moment, just for a moment. And if this were to happen with any VPN gateways, the first thing that needs to be done, and this is where a lot of things comes from ZTNA framework, is that let's try to prioritize the segmentation. Make sure. So like earlier, I was saying that what VPN by nature does is that it puts the user on the network, right? What we have to do is that we have to ensure that we need to prioritize segmentation by making sure that only the user who is supposed to access a specific application, only he gets access or visibility to that application, that is user to app segmentation, so that even if there is a potential infection, the blast radius is very limited between that user to that application. Keep on continuing the threat hunting whenever there is a VPN gateway vulnerability which is exposed for the devices which you are running in the network, right? Monitor the identity for authentication anomalies. Try the, like for example, you would deploy something like an ITDR services, because one of the things that you may want to look through is look through the audit logs of active directories, or you might want to look through some enforce some ITDR controls, right? Something like that. And then actively audit the privilege accounts that were recently created or updated, like, right? And rotate, assume compromise, always assume compromise, and rotate certificate keys and passwords. And these are the controls in case some of the organizations which are still continuing with VPN. And we actually strongly recommend, whenever there is a if there is a time for you to shift to ZTNA framework and you want to continue that VPN for some time, assume breach and keep on following these controls as long as possible, so that you would at least make sure that if there is a potential infection, it would not have chance to sort of sip through the control measures, right? And just to give you some context, I was talking about uh, uh, the Jan 10th as a benchmark, when, or rather, the start of the disclosure of VPN vulnerability. And within 2 days, Zscaler was able to identify that that exploit was running wild in the internet, is because our deception intelligence from Threat Labs was running for a lot of customers, almost 95 customers, and those 95 customers had deployed these decoys. And these decoys, just essentially what they do is that they are out there on the internet mimicking, these are like honeypots, right? They mimic the Ivanti Connect Secure or any other VPN, right? I'm just giving an example of Ivanti in this case is because this has been the recent event. But then we end up deploying these fake endpoints out there on the internet, and what they do is that they engage with an attacker, right, and giving them a false sense of notion that, okay, I'm actually a VPN gateway, and then try to consume whatever attacks that they're trying to do, and then give you high fidelity alert that, okay, fine, there is someone who's trying to do either a sponsored attack or a targeted attack towards your enterprise, right? And that gives you an early notion that there's someone who is actively trying to perform threat hunting against your organization. And what we observed during that period is there were 95 detected attacks towards these 95 customers. Again, all of them were running decoys, and they were generated from almost more than 1,500 sources. And these sources were all using anonymizer networks, right? So they were not generated from normal traditional IP addresses, right? And most of them were generated from US with almost 1041 unique addresses from Tors and anonymizers. And a large number of attacks were seen from these tier 1, tier 2 service providers. And the first alert we found was just within 2 days of vulnerability that was exposed on the out on the wild. And the way it was exploited was attacker scans and exploits 0-day, builds a persistent connection to the VPN gateway. Once it's done, performs reconnaissance for the Active Directory services, performs credential stealing, which is, I'll just, if the AD has privilege escalations or Kerberos ticket stealing capabilities or, I mean, vulnerabilities exposed, then they would essentially end up doing privilege account creation or stealing these keys and so on and so forth. And they would steal these credentials and then do lateral movement, do evidence wiping, which is the scariest one because then you do not have any audit logs to track, right? And of course, evasion for against patch and detection, because now that there are no audit logs, you would not be able to even identify anything, right? So that's the typical kill chain. While it shows Ivanti, but more or less it's same for all the VPN. What I'm going to do now is shift the gear to how ZTNA can enforce or other help organization prevent as Zscaler ZTNA help organizations prevent such type of VPN exploits. I know I sort of spent a lot of time explaining how the things are exploited, how attackers are moving and shifting in the network. The reason why I spent a lot of time there is because it's quite important for you to understand how the attacks are executed, so that you understand once you fall under ZPA framework, we are trying to break that mode of communication so that the attackers cannot figure out where the crown jewels are, and they will not be able to figure out how to exploit the framework, right? Because we are breaking the way we expose the application to the user, right? Now let's compare the architecture, right? Because it's quite important that we understand how zero trust architecture works versus a traditional VPN architecture, right? So now you have this VPN or DMZ zone where you would host VPN, and then through VPN in the data center, you would be exposing the application to the outside world. And by outside world, I mean the employees or contractors, third-party vendors, right? And these traditional remote access VPNs would have expanded attack surface because then you have your public IP exposed outside, which means you have to ensure that you are running a DDoS protection for availability. You are protecting, you're making sure that the patch management of the VPN gateway does not have any vulnerabilities and so on and so forth. And as I was talking about, by nature, even if the VPN is not vulnerable, uh, I mean, there is no CV associated with the VPN gateway. The remote access VPN by nature puts the user on the LAN, which means if there is a malware on the remote user, which is now you're not trying to expose any VPN vulnerability, but you're that since the by nature the user is put on the LAN, it can potentially just laterally move, right, and reach to Active Directory and so on and so forth. So VPN by nature becomes very uh, uh, expensive in terms of security exposure, right? So now remote user lands on VPN, and then it can laterally move if there is a malware within the applications which are hosted in the data centers, as well as to the private cloud, public cloud, wherever you have extended that into Fabric, either using P2P connections, direct connects, or maybe you can have an IPsec communication built from the data center to a public private cloud like AWS, Azure, or GCP if you're not using express routes or something like that, right? And the attacker these are can just abuse that using the attack surfaces exposed on the public IP on either side and use lateral attack surface. Now, the second part of the VPN is cloud delivered VPN, right? While this here the vulnerability availability management is completely with cloud delivered VPN, but the problem still remains is the lateral movement attack surface. Because yeah, fine, okay, I've patched up CVEs because the VPN is cloud delivered, but and the attack surfaces are hidden behind the cloud delivered VPN. I mean, the public IPs are not exposed. But again, the VPN is still allowing you on net communication, which essentially means lateral movement is still there. which means if a remote user is trying to connect to, say, suppose an application in the data center app.acme.com, and if I do NS lookup, I actually get the IP address of the data center, which means I know this IP belongs to a data center. I know this IP belongs to an AWS IP uh, VPC IP pool from VPC, and then I can just laterally move because that /24/16/27 whatever IP subnets is routable on the VPN, and that's the nature of remote access IPs in VPN, right? That's how it's designed. Now let's land on the other part of the framework, which is zero trust architecture. Now, if you look at this, workforce connects to zero trust exchange. If you see this blue icon here, right, that's the Zscaler connector, which will be deployed on the private cloud or on the data center, right? Now, what this helps us do is this Zscaler connectors represent, or rather, Zscaler connectors essentially are placed right in front of application footprints wherever they're placed. The beauty of this is that it builds an inside-out connection. Okay, this is an inside-out connection, right? There is no inward dial-up. There is nothing like that. So even if you have a firewall outside the data center, or even in the private cloud, by private cloud I mean any other data center or hyperscaler, wherever the apps are hosted, the Zscaler connector will just make an outside connection, build a mutual TLS connection with zero trust exchange, and the workforce connects to the zero trust exchange, and this all communication is mutual TLS, MTLS. No one else can snoop on it, can land on it. Point one. Point two, the connections are brokered. The connections are not routed. And by brokered, I mean the connections are terminated here, the tunnels are terminated here based on identity, posture, security controls. Separately, just-in-time microtunnels are built every time a user wants to access an application. These are not persistent connection the way VPN builds the connection. So once you dial up an IPsec connectivity, whether you're accessing the app or not, the tunnel is built till the time VPN tunnel doesn't die out, either out due to idle timeout or due to disconnection. One of the two options in remote access VPN, right? But with ZTNA, or ZPA is our terminology called Zscaler for private access. Now, what it does is, even if your ZPA is connected all the time, it doesn't matter. Till the time you're not accessing an application, the connections are not persisting. They are not built. Only control channel is built. The data plane is completely empty. It's a just-in-time microtunnel which is getting built, and every time it is validated and brokered through identity engine, posture, and obviously security assessment, right? Only then the connections are allowed, and those are also non-routable connection. Those are built on synthetic fabric, which I'll explain as we move on, right? Now, let's move to the next slide. So what are the zero trust architecture? What do we mean by that? Like, what is this? The first thing first, it's fast and direct access to private apps, right? So we, instead of bringing the user or a workforce, like the way I was talking about VPN, right? Like VPN makes user connect to network, right? In this case, the user is not connected to network, rather user is trying to connect to app. It cannot discover the network. So for instance, if I'm using a ZPA or a ZTNA framework, ZPA is the product name, just for a moment, just bear with it. Now, I would have that agent installed on the endpoint, which is called Zscaler client connector. If I'm trying to access app called app.acme.com and it is exposed through ZPA or a ZTNA framework, and if I do NS lookup, I would get the synthetic IP, 100.64 or some random IP, or whatever IP that is programmed in the ZTNA framework. It's not a real IP. It's not a routable IP. So even if there's a malware on the endpoint, it would not be able to figure out how to reach to that IP endpoint. Whereas in the VPN's case, when you are connected to remote access VPN and it is bringing your user to the network, you actually get the real IP of the applications. And the difference there is, in VPN, you are actually routed to the data center because you are actually getting the public IP, sorry, the private routable address. Here, It's all synthetic addresses. And the notion is user is connecting only to the ZPA framework and it's not connected to the user. And these are all out inside out connection. And the second part is you are brokered through the closest service edge, which means your workforce could be based working out of Mumbai or anywhere in India. Globally, my locations, my Zscaler Trust Exchange is actually placed out of 150 global locations, which means your user could be anywhere. He will always connect to the closest Zscaler Trust Exchange, and from there it will come to the data center, right? So that gives you accelerated access to reach to private applications. And this is all, as I said, like a brokered connection. These are not routed connection. Second part of this is it reduces the attack surface. And I was talking about earlier, it's a just-in-time tunnel, just-in-time connection. It connects user to apps, giving synthetic addresses and not to the network. You do not know what is the real IP. You do not know where that application is hosted. And these are all inside-out connection, which means external world. There is no VPN acme.com or any other domain name which needs to be hosted, right? This is all private to the user, right? It's completely, there is no external world exposure to reach for users to reach this application. And obviously you get a secure access to the private applications, which is by nature the need of ZTNA, where the apps are hidden behind the exchange, right? And you can do granular user to app segmentation, because what it does is that the basic principle of ZPA is that the user context has to take effect. Okay, and the user context includes the identity of user either in the form of a scheme attribute or a SAML attribute, right? Sorry, SAML attribute. Like for example, a user belongs to purchase team, right? So he only gets access to SAP, ERP systems, and HRMS, because everyone needs HRMS access or something like that, right? So that's the kind of segmentation you can build by nature inside the Zero Trust framework, right? Now, I'm going to double click here. I'm going to spend some additional time on this. When the flows are getting built either on the left-hand side context to right-hand side context. The left-hand side context is the user context, where the user is a remote user based out of office, third-party privileged user, right? And it's trying to connect to the right-hand side context, where the right-hand side context is a public cloud applications, essentially cloud workloads, data center, or whatever it is, right? So it goes through these three controls essentially: connect, segment, and protect. Connect is where I was earlier talking about. I'll be placing the connectors on right in front of applications where the connections are originated inside out, which ensures that there is no outside exposure. The agents are lightweight, which will be deployed. Like you might have two types of users. One is employee, and the second is contractor or third party user. If it's an employee, you may want to insert the ZCC agent, which is the Zscaler client connector agent. And the beauty of that is it's very lightweight agent. It, like for Mac or Windows, it just consumes less than 1% CPU at max consumption. And the good part of that agent is it can do posture check also. Like for example, if you're running CrowdStrike or Sentinel-1 or any EDR, right? It will check, are you running EDR services? Is your Windows firewall turned on? Do you have a corporate certificate? Do you have AV updated, and so on and so forth? Only when you pass these parameters, these device posture, allow access. Or if one of the critical parameters missing, allow conditional access. So you can program your Zero Trust framework and make sure that the user gets access to only the crown jewel applications, as long as he's meeting the desired security posture. Then we have this private service edge, which will facilitate the communication when the user is there in the HQ also, right? Because one of the notion of VPN, okay, is or other is okay, you use VPN when you're out of the office premise. What ZTNA tells us that a user, or like two context, user to device, user to application context, when they're trying to interact with each other, it has to go through verify, control, and enforce. That is connect, segment, protect, right? These notion, right? Whether the user is off-prem or on-prem. What private service edge does is that as long as the user is on premise in a controlled environment, instead of directly routing, instead of using ZPA services, use this private service edge, which is my private broker deployed in your data center. And even when the user is actually in the private service edge, he would not be able to figure out where the application is, and he will get same form of connectivity, the ZTNA based connectivity, even in the controlled environment, right? And the reason to do that is because while we make sure that the user, when he's outside, no malware can seep through that form of connectivity. But when the user comes back to the data center, comes back to the office, if the malware is there, it can still percolate because of how you're on the controlled environment in the routed network, right? So keep the ZTNA service turned on even on the private network so that there is no risk exposure even in the controlled environment. Then on the connectivity part, we have clientless ZTNA also, which is used for third parties, contractors, and so on and so forth, where you do not have privilege to deploy agent, right? In that case, we will use Zscaler's POP to attract the traffic using browser-based access, privileged access, to land on the Zscaler POP, and your infrastructure is still not exposed. Then perform privilege experience monitoring by tracking how when each user is trying to reach to private application. Maybe your NetOps application operations team will be able to tell that, okay, if a user is complaining, boss, I'm not able to access the application, you can actually tell them that, boss, your service provider is having these packet losses and that's why you are not able to connect, or your system CPU is running high, your memory is high, your browsers is consuming 100% CPU, so you're getting slowness accessing something, right? So that granular level experience monitoring we can tell when a user is trying to access an application. And you can give privileged user controls also through the connectivity solutions. On the segmentation part of it, day one, the moment ZTNA from Zscaler is deployed, we will be able to perform app discovery. So when the users are trying to access applications, uh, we will be able to discover, the ZTNA framework will be able to discover, okay, these are like 200 corporate applications used by 100,000, 200,000 users of your organization. And then we will run AI powered scripts on it to give you suggestions that, okay, these are the sets of users who are using these sets of applications. So maybe just carve out user to app segmentation for this so that they do not laterally move and access some other application. So that is a intelligence that we will bring we bring to the organization, because a lot of times administrators who are managing these solutions, they do not know which user should get access to which app, right? And that would only be available with either BUs or will be available with app owners, and sometimes it's not possible for everyone to come together and get to that stage, right? So this will ensure that you reach that nirvana stage as fast as possible, and we can also facilitate workload to workload segmentation in this. And with this, you will be able to completely minimize the lateral movement. Now, on the protection part of it, once you have connected everything, created a segments that which user can connect which application, protection can be enforced. Like app protection, like if it's a web app, we can enforce OWASP top 10 controls on it, so that the user, even if you know this is the legitimate user and he's just trying to learn some new CH course or something like that, and okay, let me try this on my enterprise application, right? So we have this app protection also, which will be able to detect and mitigate OWASP controls. On traffic inspection, we'll be able to do APT, sandboxing, IPS for applications which are enterprise applications. We will be able to perform data loss preventions also, because you don't want to expose that application and then someone is exfiltrating the data. You don't want user to fetch that data out of the organization for some reason. So we will be able to enforce DLP controls on it. We'll be able to perform browser isolations also on this. What browser isolation does is that if I am a corporate user, I'm working from home, I'm not carrying my corporate asset, but I need access to a business application, either to load an order or something like that, or file an expense because the deadline is there or something like that, right? So what browser isolation does is that we can host that application, expose that application from Zscaler's the browser access portal itself. So I don't need an agent in that case. Employee can be carrying his personal laptop and he will just access app.acme.com and it gets redirected to Zscaler POP. And there we will run, or rather we will render that application over isolation proxy. And what isolation proxy does is it gives you pixel streaming instead of actually delivering the HTML code to that unmanaged asset, so that you do not, because you are not in control of what is happening on the unmanaged asset. It might have some security vulnerabilities and so on and so forth. So in that case, we'll be ensuring that no data leakage, no security threats are exposed, even when for the applications which are exposed out there on the internet from ZTNA framework, right? And of course, deception could be used because by nature, what ZTNA does is, as I was telling, we end up giving synthetic addresses to private application, which means the whole network is dark. Everything is dark on the internet also. on the LAN, right? No one knows what are the IP addresses where to route on the wire. That is figured out by ZPA only, directly, automatically. Now, what deception does is that it creates these bright spots in the network, and those bright spots are where the traffic is attracted if there's a malware in the network, and that's where these bright spots will. These are like honeypots, vulnerable honeypots, which we will intentionally drop, and traffic will be attracted to it, and you'll get a high fidelity alert that there is this malware which is trying to do laterally move. It's not able to figure out anything, but it's trying to do something in the network, right? So that's what deception does, right? Now, the reason why I feel that one of the most deployed ZPA is one of the most deployed CTNA framework is because what we do today for remote user is that, again, as I said, like we end up brokering these connections through zero trust exchange and facilitate uh, zero trust communication, not just for remote users, but also for in-office users using the private service edge, the private broker that I was talking about earlier, and that makes sure that the segmentation, the security controls, whatever I was talking about in ZTNA is carried out even when the user is there in office, right? And likewise, for third-party users, we can ensure that we can create segmentation and connect contractors and third-party users using secure connection to certain apps, either hosted on OT systems in factories or AWS Azure, wherever it is, using cloud browsers, browser isolation through AI powered pixel streaming, and so on and so forth, right? So we can connect third-party users also to this private application without having VPN, without exposing direct public addresses of your factories, public cloud infrastructures or data centers. And the best part is like admins which require secure access to OT IIoT systems for RDP SSH access, right? Uh, we can expose that using what we call PRA, privileged remote access service that we run out of our zero trust exchange. So you can actually go to the portal called pra.acme.com, which can whatever subdomain that you want to configure, right? And you will see tabs like RDP SSH. You click there, and then it runs from the browser runtime itself, and then you'll be able to get the access to the factory without exposing some form of what do you call any connect clients or what is that remote desktop machines, RDPs directly to factory systems or something like that, right? So with that, uh, open call out to all of you guys. If you want to, what I would suggest is if you want to discover what is the internet attack surface for your organizations today, what threats are running for your namespaces out there on the internet, right? You could just scan this QR code and register for a free discovery call. And what we would help you do at Zscaler is that we will help you perform assessment for your internet namespaces on the internet namespaces and tell you that, okay, this is the attack surface which is there out there on the internet, and maybe potentially help you out secure that with ZPA and ZTNA framework, right? With that, I think that's the end of my presentation. If you have any queries, I think I'll just open it up for Q&A.